Hi everyone, welcome to this video where we will learn about Amazon DynamoDB. So before we begin with today's video, let me give a quick introduction about myself. My name is Aishwarya Sood and I'm working as a lead coach in the AWS domain at Ethnos. I have been into the training and development from the last 2.8 years. I'm an Amazon authorized instructor, AWS Academy accredited educator, 3x AWS certified, as you can see, Solutions Architect Associate, Developer Associate, and Cloud Practitioner, and also AWS Academy graduate. So if you want to connect with me on LinkedIn, the profile name is given here, the URL, and you can also scan this QR code to directly view my profile. So let me go through the agenda for today's video where we are going to discuss about DynamoDB. So we'll begin discussing what are non-relational databases, what is Amazon DynamoDB, and what are the core components that come within it, what are the use cases where DynamoDB will be a good fit, what are DynamoDB streams, DynamoDB global tables, and how do we do the auto scaling in DynamoDB. So in this video, we are going to discuss a few features of DynamoDB. Let's get started with the first topic, that is a quick introduction to the non-relational databases. So many of you must be aware of and would have worked on the relational databases but may not necessarily be aware of these non-relational databases. For decades, the predominant data model that was used for application development was the relational data model itself, which was used by relational databases such as Oracle, SQL Server, MySQL, etc. So it wasn't until the mid to late 2000s that other data models began to gain significant adoption and usage. But to differentiate and categorize these new classes of databases and data models, the term NoSQL was coined. So this NoSQL term and the non-relational term can be used interchangeably. It basically means the same thing. So it's a term, basically the NoSQL is a term which is used to describe non-relational database systems that are highly available, scalable, and optimized for high performance. Instead of the relational model, NoSQL databases use alternate models for data management such as the key value pairs or document storage or a graph database. In these databases, the schema is entirely flexible. The rows can have different attributes, and this model can work with unstructured and semi-structured data as well. So you must be aware of like how we create a table in the relational databases. Let's say a user table or a student table, and we will define his attributes in that. Similarly, let's say in a non-relational table, which is a graph database, so it will be like, let's say this is a user table. I'll add the user ID here, username here, user email address here. So similarly, this can work. So I can represent the information in this form as well and in the key value form as well. So we have flexibility in the non-relational databases. So few examples of non-relational databases can include MongoDB, Cassandra, Redis. And today we are going to discuss the most common non-relational database of AWS, that is Amazon DynamoDB. Amazon DynamoDB is a fully managed NoSQL database service. The complexity of running this massively scalable distributed NoSQL database is managed by the service itself because it is fully managed. This allows the software developers to focus on building applications instead of managing the infrastructure, right? Because you will get more time to focus on building the actual quality of the application, right, instead of focusing on the infrastructure. So those things are gonna be taken care automatically by the service. All you take care is the application building. It is serverless means no servers to provision, patch or manage, no software to install, maintain or update. Okay, the servers will still be there, but it's just that we do not have to manage them. And DynamoDB is very cost effective. You pay for the storage that you are consuming and the input output throughput that you have provisioned. And it is designed to scale elastically while maintaining high performance. It offers consistent single digit millisecond response times. You can build applications with virtually unlimited throughput. And as it provides ultra high throughput and low latency, so it is a good option for gaming, ad tech, mobile, and other applications that have these requirements. So you can consider DynamoDB in those cases. and the items can have different attributes in DynamoDB. Let's say the first row is having 4 attributes, the second row is having just 2 attributes, and that two different ones. The third one is having 5 attributes, and so on. I'll show you an example also. What do I mean by this? But it's since it's flexible, that's why it is having the different attributes capability, and it encrypts all the data at rest, that too by default. And also it provides the fine grained identity and access control, so you can define the access at the table level, at the item level, which is nothing but a row, at the attribute level also, which is nothing but a column. So isn't that amazing? Even that much fine grained identity and access control you are getting in DynamoDB, and it works well for the applications that handle a high volume data and that stores temporary data, and the data's nature is also simple. For those applications, DynamoDB is a good choice. Now let's have a look at the core components of DynamoDB. So as you can see in this data model of DynamoDB, there's a table, the whole thing, the collection of items and attributes. Item is nothing but a collection of attributes, which we generally call it as a row. So this is the blue line is a item, and within that we have attributes. The data elements are stored as attributes, which are, you can say, as a column or something. So these are the attributes here. And then for uniquely identifying each item in the table, we have something known as primary key. Now primary key can be a single column or it can be a combination of two columns. If you want a single key to be used as a primary key, then you have the partition key, which is mandatory for every table. You have to specify. But sometimes if that is not enough to uniquely identify the table, then you can specify the sort key as well. Let's say this is a order details table. So what will happen? User with the same ID, of course. Let's say you have registered on an e-commerce website. So you have the user ID. Now you will be placing order multiple times, right? Let's say this is your first order. So with the same ID, you will be placing the order again. But if you just use the user ID as something like, the primary key, it will create ambiguity because the user ID will be repeated. We do not want that. We want an entry to be unique in the table. So what we'll do is we'll keep the order ID as the sort key. What will happen is user ID, let's say some XYZ, and order ID is something there. This is one entry, okay, when you place one order. Next time you place an order, the user ID is still the same. That's okay because the order ID will be different. Last time there was a separate order for which there was something order ID. Now it is different. Next time also you place an order, the user ID is still repeating, but the order ID is different. So when you define a sort key, the combination of partition key plus sort key should be different. No matter if the partition key is getting repeated in other entries, that's okay. At least the sort key is getting different. So the main point to be noted here is that the combination should be unique. Something should be there which can uniquely identify each row in the table. And that will be termed as a primary key. Okay, so whether it's a single key or two keys, no matter, but it will be a primary key. Now you can see items are having different attributes. First row is having these many attributes, then second row is just having 4 attributes, third is having different, fourth is having different. Now for a particular order, there might be some details which need to be collected. Okay, for other order, there might be other details that need to be collected. Maybe not that much, but just a few details need to be collected. And then for the third order, there might be some other details need to be collected. That's why they are different attributes. That is the capability we are getting in a non-relational database. We were not having that in the relational database, right? Because if a row is having 4 attributes, the second row will have the same attributes, the third row also, fourth row also, and the same on. But here in DynamoDB, it's a flexible data model. First row is having some other number of attributes and the other rows are having other number of attributes. So this is what I meant to say when I said items can have different attributes. Let's have another example of a music table. So the primary key for the music table consists of two attributes. Okay, here we are using the partition key as well as the sort key. Partition key is the artist, sort key is song title. Each item in the table must have these two attributes because we have defined them as a primary key. The combination of artist and song title distinguishes each item in the table from all of the other orders. And all of the other entries here in the table. The primary key is done. Other than the primary key, the music table is schemaless, which means that neither the attributes nor their data types need to be defined beforehand. Each item can have its own distinct attributes, and that's what is the capability in the DynamoDB. And one of the items has a nested attribute, this one, promotion info, you can see here, which contains other nested attributes. Okay, so we have promotion info, within that we have radio station playing, within that we have the values. So DynamoDB supports nested attributes also, but up to 32 levels deep. Okay, now let's have a look at how the DynamoDB actually works. We'll go ahead in the AWS console and we'll create a table in the DynamoDB. So let's go ahead. I'll go to the DynamoDB. You can search from here. I was having it in the recently visited, so I selected from here only. So creating a table in DynamoDB is really quick. You must have worked with maybe Amazon RDS and it takes some time to create a database, right? But in DynamoDB, it is so quick. You go ahead, click on create table, give a name of the table. I'll go ahead with the music table itself because we can relate it better since we have just discussed an example for this. I'll give the partition key as singer and I'll give the sort key as song name for this table. Okay, and the data type we are keeping as string for both of them. So for this demo, I'm going ahead with the default settings for this DynamoDB table. You can customize the settings if you want. I'm not doing it as of now because we have not discussed some of these concepts in this video. Maybe we'll do another video for the next level where we will discuss these features as well. For now, let's just keep it aside and we'll go ahead with the default settings. So you can view the default table settings also if you are okay with that. If you want to make any change, you can do so by clicking here. And tags, if you want, you can add. Otherwise, you can just click on create table and the table will start getting created. So you can see it is into the creating state. Within just a few seconds, it will be active. You don't even have to wait for a few minutes. Just within seconds it will be active. So let me refresh and see if it is active. Yes, you can see it's just a few seconds, 5 to 10 seconds, and it got active here. So what we'll do now is we'll go to this table and we'll add some items into it. Okay, so that we can fetch them, we can see different details about them. So I'll click on explore item from the left navigation pane. Here I can see scan and query items. So this is for fetching the items from the DynamoDB table. Here I have got the option for creating some items. So I'll click on create item. You can see for each entry, these two attributes are necessary since they are defined as the primary key. So I'll give it as, let's say some MJ and I'll give the song name as first song. I'll add another attribute which is, let's say, not string. I want to add number instead. I'll say year of release, so I'll give it as YOR and I'll say 2019 and I'll create the item. So you can see the other attributes are optional, but the first two are necessary since they are the primary key. I'll create another item for which I'll keep the primary key, the partition key as same, because I want to show that the combination should be unique. If I write it as first song, what should happen? It should throw us an error. Why? Because item with this primary key, with this combination already exists. MJ plus first song. But what if I replace it with the second song and then I try to create an item? Yes, now I'm able to create. Although the singer is same, but the song name is different. Similarly, you can relate it with the order details table. The user ID will be same, but the order ID will be different. Let me create one more item. I'll keep it as some XYZ and we'll keep it as first song for this singer and we'll add a new attribute where we will keep a number and we'll give it as year of release. we'll give it as 2020 and let's create the item. So you can see for first row I'm having 3 attributes, for the second row I'm having just 2 attributes, for the third row also I'm having 3. Maybe I'll create a fourth item where I'll be having 4 attributes or something else. That totally depends on my need. Okay, so that is a flexibility. See, there is no fixed schema here. Okay, it's just a flexible model. So these are the items that got stored here. So we have stored the items in the DynamoDB table. What we will do is now is we will fetch that. We have two options here, scan and query. Scan is like it will scan the whole table and it will return the results. Okay, so you can apply a filter also if you have a specific attribute and you know the value of it. You can add the filter and then run it. Otherwise, you run it and it will return the whole item from the table. Query is like you have the option of defining a partition key in this table. Okay, so you can define the partition key like let's say mj and I'll say second song. Okay, so it will not waste the time in scanning the whole table, reading the whole table. It will just directly hit the item which contains this partition key and this sort key. That's it. So out of scan and query, query is more efficient and is more fast. In this we cannot see much differences in the speed because there are just 3 items in this table. But when we have other bigger tables where there are thousands of items, scan will be slower because it will scan the whole items in the table, right? And then it will return you the results. So scan will be used only in the cases when you are not aware of the partition key or the sort key. Other times query is efficient and you can go ahead. See this scan, if I run, it is returning me 3 items because there in the query I specified a partition key, but in scan I cannot specify that. So that's about creating a table and getting started with the few operations on it. We'll go back to the slides and discuss other features of it, and we'll come back to the console to see the demo of another feature. So let's discuss a few use cases of DynamoDB where it will be a good fit. It can be used as a leaderboard for your online games. So game makers can support simple leaderboards by using DynamoDB. One such use case is this ability to display the scores of your game. Let's say what is happening here is the players are there who are playing the game, which is hosted on EC2 instances, which are acting as game servers in this case. And for the leaderboards, we are using DynamoDB here. If a gaming company already stores players' game states in DynamoDB, including players' top scores, the ability to get top scores can be implemented by using a feature of DynamoDB, that is global secondary index. But you don't have to bother about that as of now. You can just remember that DynamoDB is a good fit for the leaderboards and scoring. Global secondary index and other features which we are not discussing here, we will do a separate video for that. Another use case can be to store the temporary data, the online shopping cart data in DynamoDB. Have a look here what users are accessing the online application, where on the EC2 instances there's a web store hosted where the front end is there, the products are listed, users are browsing that and they are adding something into the cart. So where is that getting stored? We are using the DynamoDB for the shopping cart storage here, and for the order processing there's another EC2 instance that is placed here. So shopping cart, why we have considered DynamoDB for this? See, when we add something into the shopping cart where there will be different products and all of them will be having different attributes, like some product will be having size, quantity, color, right? Another product will be just having quantity, or the another product might be just having quantity and color, something like that. And that data also is temporary. One, it is flexible, another it is temporary, because we are just keeping it and soon we will send it for checkout and the order will be processed, the cart will be empty. So DynamoDB is a good candidate for such a use case. Now let's go ahead to the another feature of DynamoDB, that is DynamoDB Streams. So DynamoDB Streams is an optional feature that captures the data modification events in a DynamoDB table. The data about these events appear in the stream in the near real time and in the order that the events occurred. Each event is represented by a stream record. You can have a look here. This is a table, customers table. The entries are getting stored here. They are getting captured as a stream record and they are getting stored in the DynamoDB streams. Each stream record also contains the name of the table, the event timestamp when it happened, and other metadata. Stream records have a lifetime of 24 hours. After that, they are automatically removed from the stream. So you can use this DynamoDB streams together with the AWS Lambda to create a trigger, which is nothing but a code that automatically runs whenever an event of interest appears in a stream. For example, there's a case where you have a customers table and you want that whenever a new customer registers to your application, a new item gets stored in the DynamoDB table, there should be a welcome message sent automatically to that customer. So what you do, you enable the DynamoDB streams whenever a new customer registers and his entry gets stored in the DynamoDB table. It will be captured, stored in the streams, which will be fetched by the AWS Lambda function, which will communicate with Amazon SES to send a email, welcome email to that particular email address which is stored here. Now that is one case. You can have multiple such cases where you can use DynamoDB streams to accomplish such tasks. Now if you notice, you can see here in the third entry, this person Grage, this is not having any email address, which means to this person the email ID won't be, sorry, to this person the email won't be sent, the welcome email, because there is no email address stored here, right? Now let's move to the next feature of DynamoDB, that is global tables. So by default, DynamoDB replicates your data across multiple AZs in a single region, but there might be situations when you want to replicate your data across multiple regions. So Amazon DynamoDB Global Tables provide a fully managed solution for developing a multi-region, multi-master database. You do not need to build and maintain your own replication solution. When you create a global table in DynamoDB, you specify the AWS regions where you want the table to be available, and DynamoDB performs all the necessary tasks to create identical tables in the regions that you mention. Then DynamoDB propagates ongoing data changes to all the tables. So, for example, you have a global application, okay, which can be like, let's say, e-commerce application, and you have the customers in multiple regions. Let's say in US West 2, in US East 1, or in EU Central 1. So, you want that the customers in all the regions should get a fast read-write performance for your application. It's not like that only for one region you want, but for multiple regions where the customers are located, you want good performance for them. So you will enable the global tables. Your table will then be available in all the regions and they will be referring to their region's particular table. Okay. And to note, the one point to be noted here is for working with global tables, it is necessary to enable DynamoDB streams, because DynamoDB streams will be capturing the the stream records from particular table, the one master table, and it will be replicating it asynchronously across the other replica tables. So that is necessary to be enabled here. Now let's have a look at how the global tables actually work. So we'll go back to the AWS console. We have a table that was already created. Okay, we'll enable the global tables in this particular table itself. I'll click on update settings and here I have got this option, global tables. What I have to do is, let me just click on it. I need to click on create replica. I then need to choose a region where I want to keep it. The original one is in Mumbai. So where I want to replicate it, let me select Singapore and click on create replica. It will start creating it. So soon it will be in the active state, like within 5 to 10 seconds, it will be active. Okay, then we can say, check that as well. And we'll see what all items got replicated into that. So as of now, it is into the updating state because we are creating a replica for that. That is the reason it became in the updating state. Let me refresh and see if it is active now. So not yet active, waiting for it to come into the active state. Let me check now. So as you can see, our replica table is active now. It is available in the Singapore region. So if I click on this, and I'll show you what all items have got replicated here, or if anything has got replicated or not. So I'll click on explore items and we'll see what all items are there. So there are four items. Actually, there was one more item that I created just to check. Okay, so we have the previous three items which we created, and another item also, whichever was previously existing in this table has got replicated here. Now if I create a new item also here, let me go to explore items and create a new item. Let me say some ABC singer is there who has a second song, and I'll click on create item, and I'll see here, I'll refresh. Do we have it replicated? Yes, we have got it replicated here in the replica table, which is located in the Singapore region. So that's how global tables are working. I am writing something here and it is getting replicated automatically to the replica tables. Similarly, you can create more replicas as per your requirements. I just created one to demonstrate in the Singapore region. You can create more. Now, what about the line that I said that to use global tables, you need DynamoDB streams? So did I enable in this demo? No, I didn't. But it got enabled automatically when I created the first replica. So when I click on create replica for this first time in global tables, the DynamoDB streams got enabled. You can see here the status says enabled. So this is because that all the images, whether all the records actually, whether the previous ones or the new ones are getting replicated to the replica region, because this is a prerequisite for the global tables. So that's how the global tables work. You can use them for multiple purposes. This was just one case. You can try it out on your own for various use cases. Now let's go back to the slides and wrap up this video with the last topic for today's video, which is DynamoDB auto-scaling. So the auto-scaling in DynamoDB uses application auto-scaling service to dynamically adjust the provision throughput capacity on your behalf in response to the actual traffic patterns. And to implement it, these are the steps that you will be following. First of all, you create a scaling policy which will define whether you want to scale read capacity, write capacity, or both, and the minimum and maximum provision capacity unit settings for the table. And then DynamoDB will publish the consumed capacity units metrics to the Amazon CloudWatch. If the table's consumed capacity exceeds your target utilization or falls below the target for a specific length of time, CloudWatch triggers an alarm. And you can also use Amazon SNS, that is simple notification service, to view the alarm in the CloudWatch console and receive notifications. Apart from that, CloudWatch will invoke application auto scaling to evaluate the scaling policy that you created here. And then auto scaling will issue an update table request to DynamoDB. Will adjust your table's provision capacity according to the update table request. So DynamoDB will process the request after that, and it will dynamically increase or decrease the table's provision throughput capacity so that it approaches the target utilization which we require. So this is how the auto scaling can work in the DynamoDB. And the use of this DynamoDB auto scaling incurs no additional cost at all beyond what you already pay for DynamoDB and the CloudWatch alarms. Okay, so you can get started with this by following this simple procedure and you will be good to go. So that's basically it for today's video. More topics about DynamoDB we will discuss in a separate video. I hope you have understood all the topics that we discussed today. Let's meet in the next video then. Thank you.